Hi, software engineers. Now that we're getting into testing, it's time to start talking a little bit more about our development environment and specifically continuous integration. So, if you remember from the previous videos on testing, we learned about unit testing and how important it is to test these nice little chunks of code, make sure that they're working so that, your code's working. I mean, unit tests are fantastic. They're these wonderful things that you put together so that you have more confidence in your software just, moving forward with development. Now, we hope that the developers are writing these tests. They should be the ones writing the tests. QA professionals tend to write more system level tests, but the developers are writing these unit tests along the way, making sure the code that they're building is ready to run, and they code a little, test a little, write some code, write some tests, make sure it runs. Great. But is that the last you hear from the unit tests? No. When do you run those tests? During continuous integration. Okay, we heard this before. What's continuous integration? Stay with me. Integration tests, which doesn't have anything to do with continuous integration, except they have the same word integration in it. But integration tests are when you're taking, different components of your system and making sure those connections are working well. When do you run those? During continuous integration, okay? Again, this whole continuous integration thing. What about regression tests? Well, the regression tests say you're supposed to run these, when you run the unit tests and the integration tests. Okay, fine. What is continuous integration? Okay. So the idea behind continuous integration is this. We've moved beyond the old way of building software. So many years ago, in the long ago time, when people would, write code and build larger pieces of software, what they would do is they would compile all the code together, and then overnight, typically, there would be a new build. And you show up the next morning, and you'd get the build report and find out what broke overnight. Now, this needed to happen because there were limited resources. You only had a certain number of machines that you could work with. There wasn't any such thing as the cloud or anything where you were using other services. So you'd build the code, you put it together, you'd hope to, against all hope, you do everything right. You'd run it overnight, you come back to a build report. As weird as this sounds, this isn't from that long ago. This happened to me at some of my internships when I was an undergrad, which then again was a long time ago. Wow, that's terrifying, but you get the idea. Since then, software's changed. Software is not just something that is just built one time and then shipped on a gold master disk at some point. Software ends up in beta for years on the internet. You go to a website and it's constantly in beta, and then eventually they update it. It's more, we want that first taste of the software, and we slowly keep rolling out more and more features, building out what we want it to be as we get more feedback from our customers, from our stakeholders. So continuous integration basically says, okay, in a more agile world, as the requirements are changing, and we have the ability to make these changes as we go, and to really, build out the system as we understand it better, we constantly are updating the production master branch, the mainline branch of our code, so that it is always rebuilding. Always rebuilding. And when you do that rebuilding, you rerun the tests. Because you need to make sure that, well, if you made a new build, that everything's working well. So you rerun all of those unit tests, you rerun all those integration tests, and when you rerun previous tests, that's called regression testing. So continuous integration is this idea that we are constantly updating the code base on the main branch, on the master branch, so that it is always working. And this is what we expect you to do. We expect your master branch in GitHub to always be the authoritative working version of your software. Now, you're going to make branches to go work on your own pieces of code. That's great. And when it's ready, you're going to integrate it back into master to say it's finished, therefore master is working. Master branch should never be broken. Okay? Master branch should never be broken. That's just a good tenet of software development. As organizations have adopted continuous integration, I've seen some amusing ways of doing this. So, for instance, there was one place where there was a process that was always watching master branch on GitHub, and if master didn't pass a build, so continuous integration, someone checked in their code, it reran the tests, and if it didn't pass, this office had a stoplight in it. I mean, it wasn't like a real stop. I mean, it was one of those like novelty, Spencer's Gifts sort of stoplight things. But it was hooked up to like a Raspberry Pi or something. And if the build failed, the light went from green to yellow. And then whoever broke the build had, I think, 15 to 20 minutes to fix the build before it went to red. And if it went red, then everyone had to stop whatever they were doing and fix master branch. Another good one is there were lava lamps all around the office that were connected in a similar way. And if master branch broke and continuous integration didn't pass, all the lamps turned off. Now, if you know anything about lava lamps, it takes them a little bit of time to slow all the way down. But it was this kind of a reminder like, I got to keep it live. It's kind of amusing. I like it, but there you go. So a number of continuous integration tools and services have come about over the past decade or so. And here's some right here. The one we are going to use is Travis-CI. The others are very good. They do different things. TeamCity, for instance, is the one that works directly with PyCharm. It's built by the same folks, by the JetBrains folks. But I like Travis-CI, and you'll see probably why we get into it. Now, what do these continuous integration services give you? Okay, it says you there, but my title is really long, but that's just funny, so I'm leaving that. So what does it give you? Okay, so it's an automated cloud process. So that's awesome. And so because it does that, I'm gonna skip down a few, it frees up your own resources. There's nothing that says you can't write your own scripts to do this. You absolutely can. But you have to designate your own set of machines to doing that and maintaining the scripts and making sure everything works well and yada, yada, yada. It's, we are in a software environment now where we want to pay for services that take some things off our plate if that gives us the ability to focus more on the product we are building. So, corporations pay for GitHub. Believe it or not, people pay for GitHub. I know you're used to it being free, but yeah, you pay for GitHub. You also pay for Travis. We're not. We have an educational license again. And you pay for Heroku as you spin up, more and more dynos to handle more and more traffic. So if you're not having to worry about your cloud infrastructure, your hosting infrastructure, your build infrastructure, and you can just focus on the code, all the better. So these platforms have made a business out of being easy to use, connecting directly to whatever source control management you want to use, having reporting options, doing automated deployment, and that's exactly what we want. Remember this slide from way back in the software construction? I know it was a long time ago. You're building code, and you're going to push it up to GitHub. GitHub is going to be watched by Travis. When Travis sees there's a new push to master, it's going to pull your code into Travis, build it, run your tests, and if the tests pass, it'll go to Heroku. So that's what we're going to learn how to do today. There are some prerequisites you need to work on before this is going to work. Okay? So first, you need to install the Heroku and Travis command line interpreters. Okay? Well, first off, let me back up. Only one person on your team needs to do this, DevOps manager. Only one person on the team has to do this because once it's set up, then it's set up. But to do the setup properly, you need the Heroku and the Travis command line interpreters. I've included links in the lecture notes. You can also Google for install Heroku command line interpreter. It's not hard to find. Make sure you have your GitHub and your Heroku login credentials ready. You don't need any credentials for Travis. It's going to use your GitHub credentials, which is super awesome. And I also want you to note that we are using the pro version of Travis-CI, not the free version. Now, what's interesting about Travis is they actually split these out. Travis-CI.org is for public repos. That's their open source version. Travis-CI.com is their professional version. We are going to forbid access to your projects to the .org. And there's a few reasons for this, mainly because it confuses things. But just know that we're going to do everything with the pro version. So if there's one thing that's true about me, it's that I tend to screw up demos pretty often. So I'm going to see if I can do this in one take, which would be just awesome. So we will find out. So what do we have right here? What we have right here is my GitHub repo, the staff textbook exchange. Many of you have already looked at this before. So I want to look at some of the aspects of it now. Notice that I've got two requirements.txt files here. There's different ways of managing this, but let me just show you this. My requirements.txt is super simple because it's not really an interesting project, but it has the Django Heroku thing there. But the requirements Travis does not. So for just the main reason of Travis doesn't need to have to deal with the Heroku libraries, then let's not mess with it. So we're just not. So I removed that line. So I actually have a separate requirements file specifically for Travis. Now, Travis itself, you can see it sees my repo right here, and if I remove this part, it will show me all of the repos in 3240. And right now, Project 228, good on y'all. Just a shout out to Project 228 for having your Heroku up and running, and that builds are working as of 3 days ago. So kudos, 228. Travis knows that knows to look in our organization, okay, which is UVA CS 3240-F20, and it has permissions to look in our private repos. And any repo that has a .travis.yaml file, YAML, YML, yet another markup language, haha, thanks. It will pull the code and do a build if the configuration is correct. So we're going to talk about how to get the configuration correct, right? So I've got that, I've got Travis right here, I've got my Heroku right here, I've got the app here, and here is some of the info we're going to talk about. So first and foremost, let's go into Heroku. Let's make sure Heroku knows what to do. Now, you've all done this already for your projects, probably. So I'm going to go over here to settings, and the only thing I'm going to change under deploy. I didn't even get past the first website. Dag blast it. It's under deploy. Okay. Here's the checkbox. Wait for CI to pass before deploy. Okay. So you are, by checking this here, it says, yes, I want you to wait for Travis to give the go ahead that yes, all the tests have passed, so that your software is always working when it's online. Get past it. Okay. Here I am. Let me get my cursor where it needs to be. So I'm going to do this in the Windows side of things. I mean, it's very similar on the Mac side, or Mac or Linux side of things. So the first thing I'm going to do is I'm going to do Heroku Login. Okay, so I need to log into the Heroku command line interpreter, and it's going to say open up the browser. To do this, I'm going to hit the button, and you are not going to see this because it's in my other browser. Trust me, when I've clicked things and I've logged in, now it says congratulations, you have logged in. Fantastic. Okay, now I'm going to do Travis login -- pro. Now, there's a lot of commands in the Travis command line interpreter that do neat and fun things. If something for some reason doesn't work for you, you might need to just add -- pro to the end, because that tells it, make sure you're talking to the .com website. So I'm going to do Travis login -- pro. And it's going to say, hey, I would like to log in with GitHub, please. And I say, cool, I can do that. I am Mark Sheriff. My password is that. It's probably going to ask me for two-factor. Maybe. Okay. One moment as I type in my two-factor authentication. As I get a new one. There it is. Y'all do it really fast. See if you can get that code in there. Again, I'm going to wait for a minute. Great. I have logged into both of these. So, awesome. Let's jump back over to Chrome so I can show you what it looks like here. So we can look at the travis.yaml file. Okay. Oops. Click wrong. Click here. Okay. So inside of here, you're welcome to copy and paste this in there, and some of it's going to be automatically generated. But you can take a look what's here. Language is Python. Python 3.8 install. Okay, so for the install procedure for Travis, I say when you get started, I want you to do pip install -r requirements travis.txt. Makes sense. I want you to do an install. Cool. Then the script is Python managed py test. So I'm just specifying I want you to run your PyTest. Again, great. This deploy information, deploying to Heroku. I'm going to show you how to get the secret key. The app, I've set this up in Heroku. This is the name of the app right there. Okay, and then and I give the name of the repo. Notice the formatting here, and notice the capitalization of Staff Textbook Exchange, because that's what it is in GitHub, but that's not the capitalization in Heroku, and this is case sensitive. So just be careful about that as you are doing all this. Okay, so in order for this all to work, Travis needs to have permissions to push to Heroku. And to do that, it needs the proper encrypted API key. Okay? So if I go over here and look at, that's the installation, look at this. This talks about this link right here, which is also going to be in the notes, how to do that. But the simplest version is just right down here where it shows this. Okay, Travis encrypt, and then yes, you put this in there. That's just add API key, except we're actually going to have the .pro there. So I'm actually going to highlight and copy, and then jump over to here on my command line, paste that, and run it. And what it is doing now is it is generating a new secure token, and it has now changed that file inside of my repo. I'm going to actually I'm going to say no. I'm going to say no because it's already set up, but you would say yes, and it would overwrite the file. Okay, so then that sets up that connection. Now, looking here, I'm going to do something very simple and go to textbook exchange, views.py. Okay, and I'm just going to do something hi. All class, sure, whatever. Making a change. That's all that really matters, okay? I'm making a change. So let's keep up with where everything is. Excuse me, click the wrong button. Travis, staff textbook exchange is currently good, okay? This build has happened recently. Ran 2 hours ago when I was testing my demo. Let's go back over to Ubuntu. I'm sorry, not Ubuntu, Windows. Window juggling. Now what I'm going to do is git add star, git commit dash message Travis demo. Okay. And now I'm going to do git push. All right, it is now pushed. Pushing. I'm going to go over here to Travis, and hopefully refresh it maybe. There it goes. Travis demo. So what's it doing? Okay, so it's following the instructions I gave it. So first it did an install, install git, telling you all the cool stuff that's going on. It's running. It's very exciting right now. Okay, here we go. All right, so now it's installing Python. Cool, Python was installed. Pip install. Okay, so now it's installing the pip install stuff that I want. Perfect. Hey, look, it ran my test. I had one test and it passed. It's a pretty lame test, but it's just for example. So it ran the test, and then, oh no, I did have to use the new credentials. Okay, well now we know what it looks like. So let's go back and let's fix it. So I'm going to go back over to this. I've now pushed again. Let's try this again. Go back over here to Chrome. We had the bad build. Bad build. Now, while this is going on, this is a good time to explain. This is why you want to do local testing and make sure everything is working before you push to master, because you don't want to have to do this every single time you make a small change. Real software development, you have your own environment locally on your machine, and you only are testing things like this for major things, and you let it run and you come back later. So this is something you're going to need to get used to for larger scale software development. You have to be able to build locally, test everything locally, and then when you're ready, push to master. Let's try this again. Okay, so it did a pip install again, collected Django, gunicorn, ran the tests, exploited dependencies, triggering new deployment, and now my new piece of software, which has nothing terribly exciting, might still be deploying actually. Triggering new deployment. Is it still active? Let me scroll all the way back up. Yeah, it's still active. It's still waiting for the build to finish. I mean, this is why you do it locally. Heroku's doing it. I wonder if does Heroku logs update while I'm doing this? I wonder. There it goes. That, my friends, is how you set up Heroku and Travis and GitHub to all play nice together. So again, check the lecture notes for more information about this. Rewatch the video and watch me screw up a demo again. It's great fun. If you have any questions, let us know. Thanks for hanging out. Hope this was helpful. See you next time. Bye.